This section introduces the core topic: reconstructing an image from smaller patches using Sklearn's reconstruct_patches_2d function. I'll be exploring how overlapping patches affect the final reconstructed image. It's all about understanding image reconstruction. Here's the challenge. I'm given a 100 by 100 pixel image. I've broken it into 10 by 10 pixel patches, with a 5 pixel gap between each patch, the stride. The goal is to understand the characteristics of the image once I put these patches back together. Sounds interesting, right? This is the core question. I need to evaluate 4 statements about the reconstructed image, considering how the overlap of the 10 by 10 pixel patches, with a 5 pixel stride, will affect its size and quality. Let's analyze these options carefully. This statement says that the reconstructed image will be the same size as the original, but because of patch overlap, this is wrong. Think about it: overlapping pieces add extra area. This option correctly points out that because of the overlap of the patches, the reconstructed image will be bigger than the original. That makes perfect sense. This statement recognizes that the reconstruction method averages pixel values in overlapping areas, which can lead to a loss of sharp edges and cause blurriness or artifacts, particularly at the edges. Makes sense. Averaging tends to smooth things out. This option suggests a perfect reconstruction, but this will almost never happen because of the averaging that occurs during the process of patch reconstruction. It's not possible to get the exact original back. This section sets up the concept of how overlapping patches affect image reconstruction. This is really important. This is a key observation. A stride of 5 means each patch overlaps the next by 5 pixels. This overlap is crucial to understanding the final result. Overlap is the key player here. I'm asking you this question to test your understanding of how Sklearn's reconstruct_patches_2d function works when reconstructing an image from overlapping patches. We'll see how well you grasp the concept of image reconstruction and its potential limitations. This statement is incorrect. Because the patches overlap, the reconstructed image will be larger than the original 100 by 100 pixels. Think of it like laying tiles. Overlapping them makes the final area larger than the sum of the individual tile areas. This is correct. The 5 pixel stride in a 10 by 10 patch causes overlap, leading to a larger reconstructed image. It's a direct consequence of the overlapping patches. I bet you're getting the hang of it now. This statement is also true. The overlapping patches cause averaging of pixel values, particularly at the boundaries, which might smooth out sharp details, potentially leading to blurring or other visual artifacts. Imagine blending paint colors in the overlapping areas. You wouldn't expect a perfectly sharp line between them. Nope, this is wrong. The averaging effect from overlapping patches nearly always alters the pixel values. It's highly improbable that you would get a perfect copy. We're talking about an approximation, not a perfect clone. I'm reconstructing an image from smaller pieces called patches. Think of it like a jigsaw puzzle, but some pieces overlap. I'm taking 10 by 10 pixel squares from the original image. The stride of 5 means I move 5 pixels before taking the next square. This makes the squares overlap. I start with a 100 by 100 pixel image. This is what I want to reconstruct perfectly, or as close as possible. Because of the stride, the 10 by 10 squares overlap by 5 pixels each. This overlap is key to the reconstruction process. This is a function from the Sklearn library in Python. I use this function to put the overlapping patches back together to form the reconstructed image. This is the final image after I put the patches back together. I expect it to be similar, but not identical to the original image due to the overlap. Because the patches overlap, the reconstructed image will be bigger than the original 100 by 100 pixel image. I can calculate the exact size, but it's not critical for the quiz. Because of averaging in the overlapping areas, especially around the edges, I might see some blurring or artifacts in the reconstructed image. This is a common problem with this type of reconstruction. I'm reconstructing a 100 by 100 pixel image from smaller 10 by 10 pixel patches. Think of it like putting together a jigsaw puzzle, but instead of shapes, we have squares of pixels. Let's see what you know about reconstructing images from patches. This will be fun. Scikit-learn's reconstruct_from_patches_2d is a tool I use to rebuild a picture from its smaller parts. I'm starting with a 100 by 100 pixel image and breaking it into overlapping 10 by 10 pixel squares. The stride of 5 means each square overlaps the next by 5 pixels. This is the image that I'm starting with, a nice square image of 100 pixels wide and 100 pixels tall. I'm cutting the 100 by 100 image into 10 by 10 pixel patches. The stride of 5 means that each patch overlaps the next one by 5 pixels. Imagine sliding a 10 by 10 window across the image, moving it 5 pixels at a time. That's the stride. This is the magic function. I use it to put the patches back together to form the reconstructed image. Because of the overlap, the reconstructed image will be larger than the original 100 by 100 image. And because of the averaging in the overlap areas, I might see some blurring or artifacts, like little imperfections, in the reconstructed image, especially at the edges. Think of it as blending the overlapping parts, which can sometimes create a slightly blurry effect. I'm using Scikit-learn's function. This function cleverly puts together image patches to rebuild the original image. It's like a jigsaw puzzle, but for images. Because I used a stride of 5 pixels with 10 by 10 pixel patches, the patches overlap by 5 pixels. Imagine placing 10 by 10 squares on a surface, with a 5 pixel gap between the squares. They will overlap significantly. I'm taking 10 by 10 pixel sections, patches, from the original image. The stride of 5 means I move 5 pixels before extracting the next patch. This is an important step because it creates overlapping patches. I'm starting with a 100 by 100 pixel image. This is my base image, the one I want to reconstruct from its patches. Because of the overlap, the reconstructed image will be larger than the original 100 by 100 pixels. The extra size comes from the overlapping parts. Because of the overlapping patches, the pixel values in the overlapping areas get averaged. This averaging can cause a blurring effect, especially at the edges of the reconstructed image. It's like mixing colors, the result can be slightly different than the originals. The overall goal is to reconstruct a 100 by 100 image from a set of overlapping 10 by 10 patches using. I'll learn about the effect of patch overlap on the outcome. I'm reconstructing an image from smaller pieces called patches, like putting together a jigsaw puzzle. Imagine a square image, 100 pixels wide and 100 pixels tall. That's our starting point. I'm cutting the image into smaller 10 by 10 pixel squares. The stride of 5 means each square overlaps the next one by 5 pixels, like tiles slightly shifted on a floor. The overlapping of the 10 by 10 pixel patches is key here. This overlap is what is going to affect the reconstructed image's size and quality. This is the image that I rebuild from the patches. Because of the overlap, it might not be exactly the same size as the original. Because the patches overlap, the reconstructed image will be bigger than the original 100 by 100 pixels. Think of it like the puzzle pieces extending beyond the image's edges. Due to the overlapping, the edges of the reconstructed image might look a little blurry or have strange artifacts. It's like when you blend colors where the patches meet. The transition might not be as sharp as the original. Let's test your understanding with a multiple-choice question about what happens when you reconstruct an image from its patches. Scikit-learn is a Python library. This specific function helps in reconstructing images from patches. This is incorrect due to the overlap in patches. It will not be exactly the same size as the original image. This is correct. Overlapping patches lead to a slightly larger image. This is also correct. The overlap can cause some blurring or artifacts, especially around the edges. Nope. The averaging effect of overlapping patches almost always changes the pixel values somewhat. I'm reconstructing an image from smaller pieces called patches using a technique in Scikit-learn. Think of it like assembling a jigsaw puzzle, but with potentially overlapping pieces. The original image I'm working with is a square, 100 pixels wide and 100 pixels tall. I'm breaking this 100 by 100 image into smaller 10 by 10 pixel squares. The stride of 5 means I move 5 pixels over before extracting the next patch. This creates overlapping patches. Because of the stride, Adjacent patches share 5 pixels. This overlap is key to understanding what happens when I put the image back together. This is the image I create by putting the patches back together. The overlap will affect the size and quality of the final image. Let's see what happens. Because of the overlapping patches, the reconstructed image will be larger than the original 100 by 100 pixels. The overlap adds extra pixels. Where patches overlap, the reconstruction process averages the pixel values. This averaging can cause blurring, especially at the edges of the reconstructed image. It's like mixing paints. You lose some of the original detail. Here's a multiple-choice question to test your understanding of the whole process. This is a simple multiple-choice question based on the image reconstruction process we just discussed. This option is incorrect due to the overlap we've already seen. This is correct because of the patch overlap. The final image is larger. This is also correct because the averaging of pixel values in overlapping areas can introduce artifacts. Due to averaging, the final image will almost never be exactly identical to the original.